In the 1950s, amidst Cold War paranoia, the United States Navy built SOSS, a highly classified global network of deep-sea hydrophones. The network had one primary military objective: tracking the mechanical hum of Soviet submarines crossing the ocean. But look at this network spectrogram. Amidst normal ocean static, operators detected massive, unidentifiable low-frequency pulses sitting precisely at 20 Hz. Notice the exact mechanical spacing across the horizontal axis. These pulses carried so much acoustic power, they triggered listening stations oceans apart simultaneously. A signal this loud, repeating with such precise rhythm, alarmed the Pentagon. Some Navy officials suspected the Soviets had developed a classified technology capable of generating acoustic standing waves across the Atlantic. The military wasn't the only group recording the anomaly. Geologists deploying ocean bottom seismometers to monitor the Earth's crust picked up the exact same pulses. But the data lacked the chaotic, scattered signature of a seismic event. By process of elimination, if the sound wasn't a machine and wasn't geological, it had to be biological. But an animal producing a call that could travel intact across an entire ocean violated everything scientists thought they knew about how sound moves underwater. This cross-section illustrates deep ocean physics. Water carries sound faster than air, but an acoustic wave's path is dictated by temperature and pressure. As a sound wave travels deeper, the water temperature rapidly drops. This cooling gradient slows the wave, bending its path downward. Eventually, the wave reaches a boundary called the thermocline layer, where the water temperature finally stops dropping and stabilizes. Below the thermocline, the crushing weight of the deep ocean takes over. This immense pressure forces the sound wave to speed back up, refracting sharply upward. Freezing temperatures push sound down, while crushing pressure pushes it back up. Together, these opposing environmental forces create an inescapable physical bounce for acoustic energy. This specific horizontal band, trapped between the two refraction zones, is known as the SO far channel. In normal conditions, a sound source radiates energy outward in all directions. That energy scatters vertically and quickly fades to silence. The SO far channel prevents this signal loss. It traps the sound horizontally, bouncing it between the temperature and pressure boundaries so it moves across vast distances without losing momentum. In practical terms, the ocean's physical structure acts like a massive, naturally occurring fiber optic cable designed for audio. This thermodynamic quirk is the exact mechanism that allowed the Navy's mystery pulses to cross the Atlantic intact. The Cold War anomaly was entirely biological. The SOS's network was accidentally eavesdropping on the deep, rhythmic songs of blue and fin whales. These leviathans evolved to weaponize the SOFAR channel. They generate massive pulses exceeding 180 decibels, pitched perfectly to get trapped in this deep water acoustic highway. When the Cold War ended and scientists finally gained access to this declassified military data, they realized they could use the global hydrophone network to track individual whales. This bathymetric map plots the resulting data. By following these recorded call locations, bioacoustic scientists tracked a single singing blue whale swimming 2,200 miles over a 43-day period. For centuries, we pictured whales as solitary creatures, wandering a pitch-black, lonely ocean. The physics of the SOFAR channel dismantles that assumption entirely. Researchers now observe what they call acoustic herds, entire groups of whales migrating together across an ocean basin. They may be separated by hundreds of miles of water, but they are constantly connected by the slow, rhythmic pulses of their songs. Human technology didn't invent long-distance communication. The thermodynamics of the deep ocean built a natural internet, and these animals have been using it to maintain a basin-wide culture for millions of years.